Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It is our fourth lesson on the 10th topic of Form 4, which is called radioactivity. As usual, let me comment by giving you the quote of the day, which states that you will never build yourself up by tearing someone else down. We shall discuss that quote at the end of our class today. So today we're looking at the fifth type of radiation detector, which is called a Geiger-Muller tube, usually abbreviated as a GMT. So it consists of some various parts. One, we have what we call the mica window, which is usually very thin to allow easy penetration of the radiations into the GMT tube. Then it also has a gas at low pressure, which is usually a combination of argon gas with little bromine. But the question is, why do we need argon gas at very low pressure? The reason is because it is easier to ionize argon gas when it is at low pressure as opposed to when it is at high pressure. Then the purpose of some little bromine is simply to act as a quenching agent. It also has some central wire, which is usually an anode, because it is connected to the positive terminal. Remember, an anode is a positively charged terminal. So because this particular wire is connected to the positive terminal, that is why it is an anode, or it is positively charged. Then it also has aluminium tube, which is usually a cathode, due to the fact that it is connected to the negative terminal of our battery. So you can see this, the negative terminal, then we are coming to connect it to this particular aluminium tube, hence making it a cathode. Then of course we also have some insulator here. It also has what we call a pulse counter, which simply helps us to register the number of count. Then of course we have a resistor R. So when a radioactive substance is placed in front of the mica window, of course the radioactive substance is going to emit the radiations. That is the alpha particle, the beta particle, and the gamma rays. So the emitted radiations enter the tube through the thin mica window. So we said the mica window is usually very thinner, so as to allow easy penetration of the radiations into the aluminium tube, of course, which is our cathode. So then end ionizes the argon gas. So remember, when the radiations enter through the mica window into the tube, they are going to ionize the argon gas. So it is easy to ionize argon gas because we are using argon gas that is at very low pressure. So remember, ionizing simply means that the argon gas is going to produce both the positive ions and the negative ions. So the negative ions will move towards the central wire, of course, which is an anode. Remember, from the law of charges, we said that like charges repel, while unlike charges will always attract each other. Therefore, the negative ions, because due to the fact that they are negatively charged, they are going to be attracted to the positively charged terminal, which of course is our anode. So the negative ions are going to move towards the central wire, which is the anode, due to attraction, while the positive ions are going to move towards the wall, which is our cathode. So you can see we have aluminium tube, which is the wall, which is the cathode. So the positive ions are going to move towards the wall, while the negative ions are going to move towards this particular anode. Then, as the ions accelerate, that is, as the negative ions move towards the anode and as the positive ions move towards the aluminium tube, which is the cathode, they collide with more particles on their path. So this collision results into further ionization, or what we are calling the secondary ionization. So this secondary ionization ultimately results in what we call avalanche of electrons. So remember, electrons that has been produced due to argon gas getting ionized by the incident radiations. So those particular electrons, or the negative ions, are also going to collide with the particles within this particular aluminium tube. So as they collide, they are also going to ionize those particular particles. So the particles will also consist of the positive ions and the negative ions. So as the ions accelerate, they collide with more particles on their path, resulting in further ionization. So this secondary ionization ultimately results in what we call avalanche of electrons. So avalanche of electrons is simply those electrons that has been produced as a result of the electrons produced due to ionizing the ion gases colliding with more particles within that particular GMT tube. So as those electrons collide with other particles, they are going to produce secondary ions. So these secondary ions are what we are calling the avalanche of electrons. So those secondary ions, of course, will have the electrons or the ions which are negatively charged, what we are calling the avalanche of electrons. Then, of course, in Form 1, we said that the rate of flow of charges is simply what we call current. And of course, when we talk of the flowing charges, we are specifically talking of electrons. So when the electrons are flowing towards this particular anode, it means a pulse current will therefore flow, or it will be produced, because the rate of flow of electrons is simply the definition for the word current. Therefore, a pulse current, that is a very small current, therefore flows through the circuit. Then, of course, as it flows, it can be detected by our pulse counter. So this current is amplified and passed through a loudspeaker where clicks are heard, or passed through a rate meter or a scaler where the count, of course, is registered. So the purpose of the pulse counter is simply to register the pulse current that has been produced by avalanche of electrons. So this current is amplified and passed through a loudspeaker where clicks are heard, or passed through a rate meter or a scaler where the count is registered. So the amplification usually increases the sensitivity of the tube, making it possible to register very small currents from beta and gamma radiations. Remember, we said beta and gamma radiations have very low ionizing power because they are usually light and they move at a very fast speed. So it means their ability to ionize any particles is very, very low. So the reason why the purpose of amplification is to increase the sensitivity on the tube, that is of the tube, making it possible to register very small currents from beta and also gamma radiations. Then remember that alpha particles, those ones have high ionizing power, so we don't need an amplifier in order for those alpha particles, that is, to be detected. Then the purpose of the bromine vapor is used as a quenching agent. So a quenching agent simply means it absorbs the kinetic energy of the positive ions as they move towards the cathode. So remember, we have argon gas. When it is ionized, it produces both positive and negative ions. So the positive ions are supposed to move towards the aluminium tube, which is the cathode. So we have the little bromine vapor. It is used as a quenching agent to absorb the kinetic energy of the positive ions as they move towards the cathode. This prevents production of electrons, which will cause a second electron avalanche, resulting in a false pulse. So that is the purpose of bromine. So these are very common questions. You can be asked, state the purpose of a bromine gas in a GMT, or the bromine vapor. The reason is it acts as a quenching agent. Then you can be asked, what do we mean by a quenching agent? So it is simply a substance that absorbs the kinetic energy of the positive ions as they move towards the cathode. Then what is the importance of a quenching agent? It prevents, or why should we absorb the kinetic energy of this particular positive ions? To prevent production of electrons, which will cause a second electron avalanche, resulting in a false pulse, that is, or a false count of the pulse current that has been produced. Next, we look at background radiation, whereby we are saying that when carrying out experiments using radioactive materials, it is observed that the counter registers some readings even in the absence of a radioactive source. So this implies presence of radiation. So this radiation is what we call the background radiation. So the count registered in the absence of a radioactive source is what we are calling the background count. Then let's look at some of the sources of background radiation. One is what we call the cosmic rays from outer space. 2, we have what we call radiations from the sun. 3, we have what we call some rocks which contain traces of radioactive materials. For example, when we talk of the granite. Then D, we have what we call the natural and artificial radioisotopes. So a point to note, background radiation count must be subtracted from the total count registered by a detector to obtain the actual or the correct count of the source. So in layman's language, you are simply saying that actual activity is equals to recorded activity then minus background radiation. Lastly, we look at half-life, which is denoted by T-half. The word half-life simply refers to the time taken for half the number of nuclides initially present in a radioactive sample to decay. A graph showing how the number of radioactive nuclides remaining varies with time, we call it the decay curve. So this is what we are calling our decay curve. So on the vertical axis, we usually have the number of radioactive nuclides remaining to decay. Then on the horizontal axis, we have the total time taken for that particular decay process to complete. So from the graph, the time T-half, this particular time T-half here, that is corresponding to a half of N naught. Remember, N naught is representing the original number of nuclides. So when we remain with half of N naught, half of the original number of the nuclides, the time corresponding to that is what we are calling the half-life. So from the graph, the time T-half corresponding to half of N naught is what we are calling the half-life. For example, if N naught was something like maybe 100 nuclides, so half of 100 nuclides will be 50 nuclides. So the time taken, or the time that will correspond to 50 nuclides, that is what we are calling the half-life. Simply the time taken for half the number of nuclides initially present in a radioactive sample to decay, that is what we are defining as our half-life. Then, even in the absence of a radioactive material, a Geiger-Muller tube still registers some counts. Of course, this is due to the background radiations as a result of the cosmic rays originating from the sun. So this is the formula that we use to calculate the half-life, that the number of nuclides remaining undecayed N after a given time T is given by the formula N is equals to N naught, of course, where N naught represents the original number of nuclides which were initially present in the sample. Then of course a half, then to the power of capital T. So capital T in this case simply represents the total time taken to decay. Then small t represents the half-life in this particular case. So if you want to find the half-life, you simply use this formula that N is equals to N naught, that is the original number of nuclides, then multiplied by half to the power of total time taken to decay divided by the half-life. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that you will never build yourself up by tearing someone else down. So the quote is simply encouraging us to embrace collaboration as opposed to negative competition. Remember that the most successful companies in the world usually collaborate with their competitors in order to develop world-class products for their consumers. As a student, you should also be willing to share knowledge with your colleagues so that you can all improve collectively. For instance, if you are good in English, find a friend who is good in mathematics so that you can share knowledge. At the end of the day, you will both improve in the two subjects. And lastly, recall that it is easy to destroy than to create. Therefore, good things take time to build. You just need to be persistent in your actions as you patiently wait for your positive results. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you will get notified. Until next time, this is Kind Tuition Academy. Thank you very much.